folks, welcome back. We just keep practicing, all right? Because practice makes perfect. So I'm going to keep my same sort of style here. We're going to go through a bunch of problems. And, by the way, I haven't mentioned this yet, but, pause when you need to pause. If you see a problem before I start it, give it a try and then see if you did it the same way, different way. And in all honesty, as long as everything you're doing is like legal verifying identity skills, then it doesn't matter if you have the same steps as me or, more. If you have less, make sure you're not doing too many things at once so you clearly show your thought process. So, and then as always, remember that these are your identities that you've got to know, okay? These 11 things, your 6 reciprocals, your 2 quotients, and your 3 Pythagoreans. All right. So here we go. By the way, I'm going to go back to, there's a previous video that I have somewhere that has this particular problem, and I don't think I did it in that video, so I'm going to do it for you now. All right, this is, so we've learned a new skill, multiplying by the conjugate. So I think, considering 1 plus cosine squared is not a trig identity, that we're going to need to use the conjugate for this problem, okay? And that can be a little tricky because you've got to decide, whether you want to do the conjugate of the top or the conjugate of the denominator. I think I'm going to go with the denominator here. And we're going to see if that works. If it doesn't work, I won't edit it out of the video, I promise. I will just redo the problem. Okay, so we're taking, I'm going to write this over here. The original fraction is this, secant theta minus cosine theta over secant theta plus cosine theta. So the conjugate is going to be the denominator of the denominator. So secant theta minus secant minus cosine. My goodness. All right, so that's my conjugate. Secant minus. So I'm going to multiply the top and bottom by that. Okay, and remember the whole point is that when you multiply the denominator, in this case, you multiply by the conjugate, you are going to get a difference of 2 squares. So we're going to get secant squared theta minus cosine squared theta. And then in the numerator, we are going to get secant squared theta minus 2 secant theta cosine thetas, and then plus cosine squared theta. Okay? It's a big mess. All right, so what are we going to do from here? My goal is to get sine squared and then 1 plus cosine squared. Well, I'm thinking we're going to need a fraction in the denominator. And by fraction, I mean I'm going to need to rewrite. By the way, I could turn this into a number. We'll see if that helps. But we'll save it for later. I'll explain. Maybe that doesn't make any sense. Secant and cosine are reciprocals, so they kind of cancel each other out because of that. But we'll save that. I'm going to change my secant to 1 over cosine squared. And then I've got minus cosine squared. So if I write that, over 1, I could get a common denominator. And I'd get cosine squared by multiplying by cosine squared over theta. And then I would get secant squared theta minus 2 secant. My stylus does not want to write as clearly right now. I'm so sorry, folks. 1 over cos. So in the denominator, I have 1 minus cosine to the 4th, because I have a squared and a squared, over cosine squared theta. All right, folks, at this point, there is no sign of getting sine squared anywhere in this. And while this problem is in our unit on conjugates, I've noticed 2 things while working through this problem. Thing 1, secant and cosine are not part of the same Pythagorean identity. However, silly Mrs. Fry, secant and cosine are reciprocals of one another. Let's take a look at this and try something again. What if I had rewritten those as 1 over cosine like the secants, as 1 over cosine. Let's just take a look at this. 1 over cosine minus plus cosine over 1. Well, now I go to get a common denominator between the two terms. Cosine. These are thetas. I do not know what is going on with my stylus right now, folks, but it is really not doing its job very well. This is going to give me 1 minus cosine squared over cosine. What I just wrote down, by the way, I'm going to use my yellow. This is this first fraction I just wrote down. I'm trying to use the color to kind of help clarify that. And then the denominator is 1 plus cosine squared over cosine. All right. I would like to point out that while that may have been a little bit frustrating, hopefully you can see we're already in better shape. We have 1 plus cosine squared somewhere in this problem, which is in our answer. Okay, so this equals, so here's what we're going to do. And then just to help your eyes, this part in the bottom, that's this fraction down here. Okay, fraction divided by another fraction, guess what? Multiply by the reciprocal. So just ignore all that nonsense over there. 1 minus cosine squared. Hold on, I'm going to pause while I write this down because my stylus is being real crazy, and then bam, it'll be here. All right, ladies and gents, so if you look, we're in much, much better shape. We've got a cosine in the numerator and denominator that cancel. We already have a 1 plus cosine squared in the denominator, which we want. And then best yet, 1 minus cosine squared is sine squared theta. So that is going to bring us to our answer, exactly what we wanted. Sine squared over 1 plus cosine squared. Awesome. QED, quite easily done. Not so much. But the second time, much better, right? There we go. So sometimes you win, sometimes you got to redo it. It happens. All right. Okay, number 6. So if you flip to that problem, too many trig functions. We want tangent squared in our answer, though. So let's see what happens. I'm going to flip this. 1 over sine. Oh, yeah. I'm going to want to change tangent because tangent has sine in the numerator, so this is promising. Sine squares are gone. Adios. Peace out, sine squareds. 1 over cosine squared theta minus 1. Keep our equals. 1 over cosine squared. That is secant squared theta, and then bam. Secant squared minus 1. That's a Pythagorean identity. Tangent squared equals tangent squared. Ta-da! QED. Quite easily done. Okay, not really. As I've mentioned, quadrata demonstrata, a little classical connection. All right, problem number 7. Tangent squared x times sine squared of x equals tangent squared x minus sine squared. It is much easier to combine these negatives. I'm going to start on the left or the right-hand side. I'm going to rewrite tangent as sine squared over cosine squared minus sine squared of x over 1. And I'm going to get a common denominator. Okay? Now the reason why I'm doing this is because it's a lot harder, in my opinion, to break tangent squared up and apart into two things subtracted than going the other way. So anyway, sine squared of x minus sine squared cosine squared. I'm looking at a GCF in my numerator, right? I've got sine squared in both of those terms. So I'm going to pull that sine squared of x out, and I'm going to have 1 minus cosine squared x left over cosine squared of x. All right, I see a tangent, and then I see sine squared. Hate to say it again, but ta-da! And we're done. Check that out. Another identity verified. All right, cool beans. Moving along. Ooh, that is a high exponent. Sine squared, cosine. Ooh, and a typo, folks. I don't know if it's also a typo in your notes, but there should be an X right there. Okay. So we need a bunch of cosines. Like a lot of them. We've already got one. We need 4 more. Well, this guy is likely going to factor. But before we factor it, it has a GCF. Everything has at least a sine squared in it. So I'm going to pull out a sine squared of x as a GCF. And so that's going to leave me with 1 minus 2 sine squared of x plus sine to the 4th of x. Okay, so this is like having 1 minus 2 x plus x to the 4th. Sorry, x squared. So that's going to break up into, 1 minus x squared, 1 minus x squared. That looks like a perfect square situation. So that's going to be 1, if I kind of think about it that way, it's going to be 1 minus sine squared x times another 1 minus sine squared x. All right, okay, so we've got cosine to the first power, sine to the second power, and then each of these guys is another cosine squared. Cosine squared. It's like I'm just collecting cosine squareds. So there we go. Ta-da! I'm just really trying to show you the magic that is the math. So cosine, I'll write it the same way so we don't get all mixed up. Sine squared x, and then we've got cosine to the 1, 2, 3, 4, 5. Cosine to the 5th power. All right, okay. I think we're going to have time for one last problem. I think there's a couple more in your notes packet. Yeah, number 10. But I think the only one I'm going to have time for, last but not least, is number 9. And the reason why is because, fair warning, I do know this one. It's going to have a lot of fractions, okay? Definitely going to start on the left side, for sure. Okay, so the numerator. Let's get a little bit of purple going on in here. Okay, so the numerator. I'm going to change that to sine of theta over cosine of theta. Hopefully, at this point, we all know where that cosine came from. It came from the secant. Okay, and then the denominator. Sine over cosine plus cosine over sine. I'm using the colors to help identify the different pieces. All right, now I get it. It looks like a hot mess. It's going to be fine. It's really going to be fine. You just got to keep track of where your fractions are. So I need to multiply this guy on the left by sine over sine. And I need to multiply this guy in the denominator on the right by cosine over cosine. The top's fine. I'm leaving the top alone. Okay, so sine of theta over cosine. It's got to get a little bit messy before it can get better, but I promise it's going to get a lot better. Over. Okay. I'm going to pick some like pink color, just so it's totally different. Okay, this part right here is sine squared over sine cosine, okay? And this guy over here is going to have the same denominator, so I'm just writing it in the same fraction, and it's got cosine squared in the numerator, okay? So I kind of did two things at once. It's going to be fine. I combined the fractions, multiplying, and then added. I just wrote the two numerators in the top, sine squared and cosine squared. Okay, here's the big move. We've got a fraction divided by another fraction. That's a crazy mess, but I could rewrite it as its reciprocal. So that's going to be sine times cosine. That's the denominator, so I'm flipping it over, and then sine squared theta plus cosine squared of theta. Hopefully you know where this is going. This guy, this is 1. Oh, that doesn't look very clear. That is 1. Okay? Cosine over cosine. Adios. I am left with sine times sine. Sine squared. Ta-da! You're probably sick of hearing me say that. But Verifying identities has a lot of ta-da moments, all right? Okay, so it got a little messy, but we cleaned it up pretty quickly. Folks, thank you so much for listening. I hope that this helped. See you soon. Bye.